Alright, a quick question. What's the difference between an API key, a JWT, or OAuth, a bearer token, or even something like single sign-on? Most of the developers hear these terms all the time and assume they all mean the same thing, but they are not.
Hey, this is Rajasthar and welcome to the channel. Today we are going to break down authentication in a way it actually makes sense. And the easiest way to understand all of this is to see how these methods evolved over time.
Some of these define how credentials are sent over HTTP. Some describe how authentication state is maintained. Others are just token formats, while a few are complete identity protocols. And the easiest way to understand all of this is to look how authentication has evolved over time. Let's start with one of the earliest methods, basic authentication. In basic authentication, the client sends a username and password with every HTTP request using the authorization header. These credentials are encoded using base64 and attached to the request. But the base64 is not encryption, it's just encoding. So if HTTPS used, anyone intercepting the request can easily decode the credentials. Because the simplicity, basic authentication was widely used in early systems. However, sending credentials repeatedly with every request make it insecure for modern applications. So, to improve the security, digest authentication was introduced. Instead of sending the password directly, the server sends a challenge. The client then uses the challenge along with the password to generate a hash response. The server side validates the hash instead of a raw password. This approach avoids sending actual password over the network. Even though it's more secure than the basic authentication, it's more complex and not commonly used today. As web applications became more popular, a different model emerged, session-based authentication. When a user logs in, the server creates a session and stores it. A session ID is sent back to the browser, usually through a cookie. For every subsequent request, the browser automatically includes that cookie. The server reads the session ID and identifies the user. This works well for traditional apps, but it requires a server to store a session data, which became difficult to scale across the multiple servers. To solve the problem, modern systems moved toward token-based authentication, and one of the simplest forms of this is the API key. An API key is a unique identifier assigned to an application or developer. The client includes the key in request, so the server knows who is calling that API. API keys are commonly used in public services like maps or payment APIs. However, they usually identify the application, not the individual user. As distributed systems and microservices became more common, bearer token became widely used. With bearer authentication, the client sends a token in authorization header using the format bearer token. The term bearer means whoever has the token can use it. The server verifies the token and grants access. This approach removed the need of server-side session storage. However, bearer token must be handled very carefully, because if someone gets access to the token, they can act as that user until it expires. Many bearer tokens today are implemented using JSON Web Tokens or JWTs. A JWT is not a protocol, it's just a token format. It contains the structured data about the user in a JSON payload, and it is digitally signed by the server. This signature ensures the data hasn't been altered. Because the token itself carries the required information, the server doesn't need to query a database for every request, making JWTs ideal for distributed systems. In real-world systems, tokens are typically used in two forms: access tokens and refresh tokens. Access tokens are short-lived and used to access protected APIs. If compromised, they only provide limited access for a short time. Refresh tokens are longer-lived and are used to generate new access tokens. This allows users to stay logged in without repeatedly entering the credentials. As applications became integrated with third-party services, OAuth 2 became essential. OAuth is an authorization framework that allows applications to access resources on behalf of a user without exposing the user's password. For example, when an app asks for access to your Google Drive or GitHub account, OAuth is being used. The user authenticates with the provider and the application receives an access token with a limited permission. OAuth focuses on authorization. That means what an application is allowed to do. However, OAuth does not define how to verify a user's identity. That's where OpenID Connect or OIDC comes in. OpenID Connect builds on the top of OAuth and adds an identity layer. It introduces an ID token which contains a verified information about the user. This allows application to confirm who the user is without handling the password directly. Modern login systems like sign in with Google are built on OpenID Connect. Finally, there is a single sign-on or SSO. SSO is not a protocol, it's just a user experience. It allows users to log in once and access multiple applications without signing in again. For example, logging into your company's account and automatically accessing email, dashboards, and internal tools. Behind the scenes, technology like OpenID Connect or SAML makes this possible.